Hi ROS developers, and welcome to this ROS helping videos. If you want to learn anything about ROS, this is your channel. ROS navigation with drones, autonomous cars, everything you want to know about ROS. Here you can learn it. Learn ROS step by step and push your ROS learnings in just 10 minutes video, like this one. I'm Miguel Ángel Rodríguez, and today I'm going to show you some simple programs that you can build to test your odometry, that the odometry in your robot is working, and measure the distance that the robot is moving. So in this case, we're going to use Robotics Academy for this, and we're going to use the ROS Basics in 5 days course for Python. So when you sign in and make an account, you can get access to this course. And if you go to services, ROS services part 2, you'll get something like this. So you have your BB8 simulation and your IDE and the notebook with the exercises and so on. But in this case, we're going to concentrate in doing this program. So for this, I've already done it, and I'll show you step by step more or less how to do this. So the first thing is creating a ROS package like this one that I created here. How do you create a package? Very simple. You just go here to the web shell and you see that in user you have a Catkin workspace. You just go to the Catkin workspace, go to the source, and here you create a package with the command Catkin create package, then the name, let's say, I don't know, test BB8 package 2. It's very important that you don't have packages with the same name in your workspace, otherwise you'll get compiling errors. Robot Ignite system will detect that for you, but if you work in your own computer, you have to bear that in mind, because you won't have anything that tells you until you compile. Okay, so you put the name and then you put the dependencies, in this case just ROS.py, because we are going to use Python bindings for ROS. Okay, then any other dependencies that you have, like, I don't know, navigation messages package or whatever you are using. In this case we only need this, and automatically we'll get this in the IDE. And you'll get something like this. As you can see, here we have an extra folder, which is scripts, which is the place where you should put your Python scripts instead of source. Here you should put more source files and Python modules that you use as imports. Yeah. So we just create a folder like this, very simple. I mean, it's not space science. And inside here, you'll put all your scripts. Yeah. So in this case, we have it already done. And I'm going to show you what you need. So I've made 2 Python scripts. The first one is one to move the robot. So in this case, I've created a class which is called move BB8, and inside it, we are publishing in the command vel. Yeah. If you want to know how to do this, please start this course from the start, like unit 1, 2, and basics and topics, and you learn everything you need to understand all this. But for the people that understand, let's continue. So the thing is, you are publishing in command vel, and you're creating this BB8 velocity publisher. Okay. Then when we want to move the robot, we are using, in this case, if we go to the execution main, you see that we create this move BB8 object class, and then we do this movement distance test. In this case, I've made these classes, and for example, you see that we execute move 1 meter, which is this class here. And here we have move x time, which is the moving time, linear speed, and angular speed. And as you can see, this function is the moving time, linear speed, and angular speed. What's important here? Well, basically we are creating an object twist with the linear speed in the x and the angular speed in the z, angular z, okay? This is something that it may cause problems because you may say, okay, I want to move in the x axis, in the y axis. It doesn't work like that. You are saying, okay, you have to move in the x. Linear means move forward. And when you publish in the angular z is turn. And with those two combinations, you'll get a movement throughout the plane. Okay? You're not saying, okay, move in the x or in the y, and then you move like xy movement like this. Okay? Doesn't work like that. It's more works like a differential drive, but it depends on your robot. But bear this in mind in the case of people that are doing the course. And then we have this publish once. This is very important because when you publish topics are made for continuous publishing. So it may cause problems if you only publish once because it may not publish the first one. And if you rely on that, you have to publish once and that's it, and it has to get it, you have to create this function. I'll leave a link in the description below where we have a video explaining exactly this, how to create this function, which basically checks that that there's a connection, that the topic is listening, okay? And that's it. So we publish the command value that we need, and that's it. Okay, this is the movement. Now, more on the odometry side. So for that, I've created this script, which has this BB8 movement detector, which does two things. One is a subscriber to Odometry, and another one is a publisher to this BB8 moved distance, which will publish the distance that this robot has moved. Yeah? Okay, fair enough. So you should create this class, which is called BB8 movement detector. You have this initialization, which is creating this moved distance object, which stores the distance that it has moved. Then we create this publisher and this subscriber. The important parts, well, basically this odometry callback, because every time that our robot publishes in odometry topic, which if we go here and we say, okay, ROS topic list, we do a grep odom, you see that effectively we have this ROS topic echo odom and one. As you can see, it's quite complex topic, but basically we have the position, orientation, and then the twists, like the speed at which it's turning and moving. Okay, but basically we are looking at this, the position. In this case, as you can see, it's in the 0, 0 and has in the Z just the distance, because the odometry is not in the plane, it's around here in the center of the robot, so there's like 0.3 meters, which is the radius of the sphere of the BB8 in this case. Yeah. So yeah, we have odometry. So when every time this topic publishes, we will call this callback and we will get the position, which is pose.pose.position. Remember? Let's have a look at this published. So odometry publishes this structure, so it's pose.pose.position. It's a bit confusing, bear that in mind. Okay, once we have it, we just have to calculate the distance. For this, we have to have the current position, which if we have a look, So the initial position, you see, it's initialized at the start in the init function of this object, a BB8 movement detector, which what it does is stops and listens to the odometry, and when it gets the first message, it updates, it stores the current position to the initial the initial position that we have. So in this case, this one, which is the one that we are reading right now here. Okay, this is in the initialization of this class. So we come here and we get the new position, and with that one and the current position, we calculate the distance that it has moved. Yeah. So calculate distance, very simple, just trigonometry, nothing very fancy, and we store this distance. So return distance. We don't store it, we just put it here, and then we store it around here. So BB8 move distance, and this one is the one that will be published. Yeah, you see, if the move distance is lower than a value, we just put 0 because it doesn't make any sense putting very, very big numbers that are really very small, like E, like this one, for example, like 2.16 E minus 23, that's 0, unless you need very high precision. So instead of that, we just publish 0, and when it's bigger, then we publish the move distance. Okay? And that's it. I mean, it's not space science here, but there are some very small steps which you have to bear in mind, and how to make it work. Well, that's the, I think, simple part. So we have it already prepared. So you do ROS run, then the name of your package and the Python. Check that your Python is executable. How do you do this? Well, let's have a look. So ROS-cd test BB8 then scripts ll, and you can see that is executable. Okay, so bear that in mind. So let's continue. So here we will execute the movement. Here we will execute this test BB8, the BB8 movement detector, which it's printing all the time the latest position of odometry so that we can see. And here we're going to read the command velocities sent, and here we're going to let's ROS topic echo, and we're going to read the distance traveled, the total distance traveled. Okay, there we go. So we can start the echoes. You can see it's nothing published for the moment. Then the movement detector, which what it will do is read the current odometer position and consider it the first position. There we go. So now we have, this is our position, so basically 0, 0 in X and Y. We don't put Z because this robot doesn't fly. And then we do the ROS run test BB8, which if we go here to the move BB8, we see that the move distance test is we are moving in the y-axis 1 meter, then we turn, and then we move in the x-axis. And in the y-axis, if we go to this move meter, what it does is go forward and then go backwards, this one. So back. Yeah. Back. Okay. So it goes backwards. And every time that we do, we stop and wait for a few seconds so that it has time to stop the inertias and the movement. This is very important because we're not reading directly the odometry to move, so we are in an open loop. So we go here and we start the movement. Let me put this, maybe we can, no, like this is okay. There we go. Turning. And there we go. So as you can see, it's moving in the X and in the Y. Let's execute it again so that we can see it. So, we haven't seen it, so we read here. As you can see, it resetted the positions, and we reset it with this button. So we reset all the positions, okay? So yeah, we have this 0. And as you can see, let me, okay. As you can see, it's getting the distance 1 meter in X. And 1 meter, right? Okay. And we've moved around, yeah, like 3 meters because we moved 1 here and then here and then back again. And that's it. And more or less we end up like here. We moved in Y 1 meter, and then in X we moved like here and then back again. And that's it. In the description of the video you will find the complete course on ROS Basics in Python and the resources mentioned. If you like the video, please leave a thumbs up and consider subscribing and hitting that bell to get the latest videos that we publish every day. So thank you and see you in the next video. Hasta la próxima.